Okay guys, so let's continue by question number 6. Okay, so this is the question. An aluminium wire, initially 2.45 meters long and diameter is 1.5 millimeters, is suspended from a rigid support with a load of 15 kilograms attracted to its lower end. Young modulus of aluminium is 7 exponent 10 Newton per meter squared. So they ask you to calculate the extension of the wire, also the strain energy stored in the wire. Alright, so as usual, you just pointing out all the info given using a symbol. So this is L0, this is the diameter, and then this is the mass, and this is the Young modulus. So I think better we just convert everything given to be in SI unit, mostly for the diameter here lah. Alright, so how was the situation? This is okay, by having a simple diagram. So what do we have? That this is the wire and this is the mesh hanging now. So seems like the force exerted on the wire is the tension which is caused by the weight, isn't it? So at equilibrium, T minus W equals to 0, so that T equals to W, where T is the force exerted on the wire lah, which is the tension. Alright, so for the first question, they ask you to find the extension of the wire. So how do you find the extension, which is E, elongation? So using the Young modulus equation, which is Y equal to FL naught over AE. Alright, so the force exerted on the wire is the tension now. This is L0 and the area is pi d squared over 4 because the diameter is given here, and then multiplied by E. So we just substitute the value of tension. Tension equals to W, which is mg. Okay, and then this is the original length, which is L0, pi d squared over 4, and E equals to the Young modulus, which is 7 to the power of multiplied by 10 to the power of 10. Alright, so by calculating everything, and then you will get the elongation or extension, which is equals to 2.91 exponent negative 3 meters. Okay, next question, for the second part, which is B, they ask you to find the strain energy stored in the wire. Okay, so from the equation of strain energy, which is equal to half Fe, again the force exerted on the wire is the tension, so that we just substitute tension equals to mg, and this is the elongation calculated before in A. Substitute into this equation so that you will get the strain energy stored in the wire is 0.21 joule. Okay, so remember the force now equals to the tension lah, alright, which is the force exerted on the wire, which is caused by the weight hanging now. Alright, and then for question number 7, okay, the question now is, by giving you the diameter of a circular shoe heel is 13 centimeter. Okay, circular shoe heel. Okay, so this is the diameter given, so that we may calculate the area. If both heels support 70% of the weight of a 54 kilogram woman, calculate the stress on both heels. Okay, so now they ask you to find the stress, and by giving you the diameter of the shoe heel, and then the weight support by the both heel now is 70% of the weight, which is 54 kilogram. This is the mass of that woman. Alright, so as we know, by giving you the diameter, which is 13 centimeter, we just convert it to be in meter, you will get this. Then we may calculate the area. Area equals to pi d squared over 4. Okay, the diameter we just substitute here, and then you will get the area of the shoe heel now is 1.33 exponent negative 2 meters squared. Okay, so this is for one heel only. Okay, but as we know, the weight support now is 70%, the force support is 70% of the weight. So weight is mg, so this is mass given 54 kilogram, and this is our g, so mg representing weight, but the heel just support 70% of the weight, which is 0.7 lah, and that one is 70%, so that the force support now is 370.82 newtons. But remember, this is the force support by both heels because we have two legs, isn't it? Okay, so that this is the area for one heel only. So in calculating the stress equal to F over A. So this is the force support before calculated just now, and the area should be involving both heels. Okay, so we need to multiply by 2 lah. And this is the area of one heel, and then for two heels, then we need to multiply by 2. So we just substitute the values here, and then you will get the stress. Okay, next for question number 8. Alright, so what do we have now? Okay, this is the question. So a 1.5 meters steel wire is stretched 2 millimeters by a force F. The diameter of the steel wire is 4 millimeters. The Young modulus of steel is 2 times 10 to the power of 11 Newton per meter squared. Determine the force applied on the wire. Alright, so what do we have now is the original length, which is 1.5 meters. The elongation given now is 2 millimeters, convert it to be in meter. The diameter given also in millimeters here. We just convert it to be in meter. Then this is the Young modulus given. So based on that, they ask you to find the force, which is F. So using the Young modulus equation, which is FL naught over AE, by rearrange the equations, you will get F equal to YAE over L naught. So remember, A represented the area is pi d squared over 4. Alright, and then we just substitute all the values given here, which is the Young modulus, and then this is the diameter. Alright, and then this is the elongation given, which is 2 millimeters before. Alright, and this is the original length, which is 1.5. Then you will get the force is about 3,360 newtons. Okay, so it's quite easy, isn't it? We just use the equation directly. Okay, alright, next question, which is number 9. What do we have now? Okay, a copper wire of length 3 meters and radius 2.4 millimeters stretched by 1.5 millimeters when the load is suspended vertically at its end. So as usual, please check the unit. Okay, this is the trick of the question lah. If the Young modulus of copper is 1.2 times 10 to the power 11 Newton per meter squared, determine the mass of the load. So again, what do we have now? The original length, which is 3.0 meters. The radius given is 2.4 millimeters, convert it to be in meter. And then the elongation is 1.5 millimeters. Again, we just convert it to be in meter. So the Young modulus given 2, then they ask you to find the mass. Alright, so again, this is the situation. What do we have now? Just a wire, and they're connected to the mass. So the force exerted on the wire is the tension, which is caused by the weight, isn't it? So again, T minus W equal to 0, giving you T equals to W. So this is the force exerted on the wire lah, which is the tension. Okay, so what happened now? According to the Young modulus equation, which is FL naught over AE. So the force is tension. So still the same actually. Alright, so the tension now equals to weight, which is mg. So T is mg, this is L naught, and the area is pi r squared. Why? Because the values given is radius. Okay, we just use the radius directly, and then this is the elongation. So by rearranging the equations, we need to find mass. So mass equals to y multiplied by this, okay, and then divide by g of L naught. Okay, and then we just substitute the value of y, the radius, the elongation, also G and L naught, so that you will get the mass, which is equals to 110.7 kilogram. Okay, lastly for question number 10. Alright, so what do we have now for question number 10? So read the question first. So we have two different parts, which is A and B, where these two questions are different. Okay, the first one. But a wire originally 2 meters long suffers a 0.1% strain. What is its stretch length? Okay, so by giving you the original length, also the strain. So what is the original length? What is the total length? Okay, what is its stretch length means that the total length lah. Alright, so what do we have? L naught given is 2 meters. The strain given is 0.1%, still equals to 0.001. We just calculate the values, which is 0.1 divided by 100. Okay, giving you 0.001, and they ask you to find the total length. Alright, so total length equals to original length plus the elongation, where elongation equals to, okay, from the equation of strain, which is ratio between elongation and original length. So the elongation is equals to strain multiplied by the original length here. Substitute it into this equation, giving you this. So original length given is 2, strain is 0.001, and L naught again equals to 2, giving you the total length after the stretch now is 2.002 meters. Okay, and then for the second part B, a length of copper of square cross section measuring 1 millimeter by 1 millimeter. So remember, the wire just in square shape, so the cross section area should be square, which is 1 times 1. Okay, but remember the unit is millimeter. We need to convert it to be in meter for the calculation. So it's stretched by a tension of 40 Newton. So this is the tension or the force exerted on the wire. So what is the tensile stress in Pascal? So they ask you to find the sigma lah. Okay, so the area is 1 times 1 millimeter, giving you 1 millimeter squared. So 1 millimeter squared equals to 1 times 10 to the power of negative 6 meter squared. So remember, milli is 10 to the power of negative 3 multiplied by 2, giving you negative 6. Okay, and the tension is 40 Newton. They ask you to find the stress. So stress equals to F over A, where F is the tension, which is tension over A. Tension given is 40 Newtons, and the area is 1 times 10 to the power negative 6, giving you 4 times 10 to the power of 7 Pascal. So remember, the trick still for the unit. Okay, remember that for any calculation, please convert everything to be in SI units. Okay, I think that's all. Thank you.